Are you tired of making dull, boring plots that look like this? Do you want to spice them up, add a little bit of color, and make them truly pop like this? If you answered yes to these questions, then this is the video for you. Hey everyone, welcome back. It's me, the part-time economist, and in today's video, I'm going to be showing you how to create and customize a density plot in the R programming language. Now, this is a beginner-focused tutorial. If you're a super advanced user, you might find this a little bit slow, but again, this one is for the beginners. We're going to break everything down nice and simple, step by step. I'm going to assume that you have absolutely zero experience with the R programming language. So with that being said, let's go ahead and jump right in. Now, there are lots of ways of doing the same thing in R. The way that I'm going to show you today is by using the tidyverse. I think it's one of the best ways of doing these type of things because it's easy to transfer skills that you learn on one plot to another. But again, we don't need to get too much into that. Let's go ahead and jump right in. So the first thing you're going to do is install install. You're going to go install packages, and then you're going to install the tidyverse. This is the collection of data analysis packages, the plotting tools that we're going to use in the video. Now, the important thing to understand is that once you install a package, you also have to pull it into your workspace every time, every new session that you use it with, right? So we're going to go with library, and we're going to pull in tidyverse. All right. And okay, now we have everything we need. Now, for today's video, we're going to be working with the diamonds data set. This is just a collection of various diamonds and their attributes, right? So we've got the cut, the color, the fill, the clarity, the price, everything like that. Now let's suppose we want to create a density plot of the price of these diamonds. How do we do it? Well, the way that we're going to do that is by using ggplot. Now, ggplot, it's important to understand when we create graphics in the R programming language, specifically using ggplot, we are essentially creating different layers of graphics that all build upon each other. And that might not make sense now, but it will in a minute, right? So the base layer of our plot, the base layer graphic is going to be that ggplot function, right? This is the base canvas that we're working with. Now, inside of this, we have to tell it what data are we working with, and we're going with data equals diamonds. Now, keep in mind, I'm working with diamonds. This is a sample data set. If you have imported some kind of data, and let's suppose it's about the stock market, right, and you called it finance data, here you would call data equals finance data, right? It needs to match. So this is just telling ggplot what data set are we looking at right now. Obviously, there are lots of different aspects of this data set, right? We have price, we have color, we have cut, we have clarity, right? We have all of these things going on. So we need to tell it, what are we even looking at here? And we do that using the AES command. Now, AES stands for aesthetics. Now, for me, this is easy to remember because aesthetics is how something looks. So aesthetics is telling ggplot, how does this chart look? Well, we know on the x-axis we want PRICE. Now, we know we want price, but why am I typing PRICE? The reason I'm typing PRICE is because that is the column header. That is the name of my variable here. If you were working with that finance data set, right, and let's suppose you had all these stock prices and one of them was for Coca-Cola, right, and you called that KO, and you wanted to visualize the density function for Coca-Cola, instead of typing price here, you would type KO, right? It needs to be the name of that column header. Now, what you're going to notice when I run this, it does not give us what we want, right? Why does it do that? Because remember, like I said, when we're working with ggplot, it just creates that base canvas, right? It is layering graphics on top of each other. So we have price on the axis here, that's great, but we've not told it what kind of picture to draw. And the way that we do that, we go with geom and we go with density. Now, you'll notice there's a ton of different geometries we can use. That's why I love tidyverse. That's why I love ggplot, because all of these customization skills that you learn with a density plot, they can carry over to a bar chart or a line chart, something like that. But again, I don't want to get too off topic. Here we are just working with geom density. And now what you're going to notice is that it does create that for us. Now, obviously, this is probably the most uninspiring density plot you've ever seen in your life, right? But it is something, right? We have made some progress. So how do we customize this? How do we make it a little bit better? Well, a couple things that I do want to show you. So when we're looking at this, we see that there are lots of different characteristics of our data, right? We have different cuts, we have different carats, we have different, all of these things, right? And it would be plausible to assume that the price of a diamond is also influenced by its cut or its color or its clarity. So how can we differentiate this graph? Well, the way that we do that, we come back up here into AES, right? We have X equals price. What we're going to do now, we're going to go with COLOR, and we pass in a second variable name that we want to differentiate with respect to. So let's suppose I want to differentiate with respect to cut, right? What that's going to do, it's going to change the color based on the cut. Now, when we pass in color, it is going to change the line color. Let's suppose instead we want to change the area, right? The area underneath this graph. The way that we do that, instead we go with fill. And what that's going to do, it's going to change all of this. Now, by default, it is going to give us these nice solid colors. If we wanted a little bit more transparency, we would do that using the alpha command. So alpha, it just means transparency. Now, you'll notice that we put this inside the geom density and not the aesthetics function. So we're going to go with ALPH. Oops, let's make sure I spell right. ALPHA, HA, and we're going to go with equals 0.5. ALPHA. I will tell you all, it is a lot harder to talk and type than it looks. So, okay, we are good to go there. Now, this is looking a little bit better, but if we turn this in for an assignment, we're probably not going to get a good score, right? Because there's no title. So let's add a little title. Let's go with LABS. Let's go with title. And let's go with diamond price. Okay, perfect. So we've got the price of the diamond. Let's suppose we also want to change this x-axis. We can do that by going x equals PRICE. And what you'll notice is that by default, when we create a density plot, R is going to automatically label that y-axis as density. And the reason it's doing that is because we're creating a density plot. Like, it knows that's what the y-axis is for. But just for consistency, let's suppose we want to have that in caps. So we're going to go with DENSITY. Now we're looking much, much better. But we don't just want good, right? We want this to really stand out. We want this to really pop. So let's also go over here. See where this says cut? We don't like that, right? We want to denote that this is the legend. So this is where things get a little bit interesting. You're probably thinking, okay, title adjusts the title, X adjusts the X, Y adjusts the Y. So legend should adjust the legend, but that's not actually the case. So we differentiated this with respect to cut. So when we change this label, we're actually going to pass in cut, right? Or sorry, we differentiated this with respect to fill. So I'm getting myself confused here. So, okay. So when we differentiated this aesthetics, right, we did it by using the fill command. So instead of typing legend, we're actually going to type fill equals, and we're going to go with we're going to go with LEGEND. Now what that's going to do is going to change it. So if instead of doing fill, we had done color, then instead of fill down here, we would also put color. So, okay, perfect, looking good there. Now let's get into the really heavy-duty customization. So we're going to go with theme, THEME, and inside of here we are putting everything else that we want to customize. So let's suppose we want to start off by, we want to center the title, right? We're going to do that by going element oops, sorry about that. We're going to go with plot dot title. We're going to go with element underscore text. And don't worry, I'll explain what all of this means in just a second. HJust equals 0.5. Color equals, we're going to go with hot, PINK. Now, let me explain what each of this is doing. So when we customize the theme, the first thing we have to do is tell our what aspect, what object within this plot do we want to work with, right? Are we doing the title? Are we doing the background? What are we doing? Then we have to say what aspect of this title do we want to adjust. Now, I used element text because the title, it's words, right? It's letters, so I'm using element text. And then once we say, okay, this is the object I'm adjusting, this is the aspect that I'm adjusting, here are the specific items that I want you to change. So HJust stands for horizontal justification. So I did 0.5, right? 0 is going to be to the left, 0.5 is in the middle, 1 is to the right, and then color equals hot pink. So let's go ahead and let's do panel dot background. So you'll notice I'm telling it, now I want you to adjust a different object on the plot. I'm going to go with element. Now what you'll notice here is that I do element rect. Why am I doing that? Well, I'm adjusting a background. That is a geometric shape, right? There's no text there, so I need to use element rect. And I'm going to go with fill equals black, B-L-A-C-K. That's going to change the panel. Now I also want to change this plot background. I'm going to do pretty much the exact same thing, except it's going to be plot dot background element. Again, it's going to be element underscore rect. Fill is going to be black. Now you might say, why am I not using color? Why am I using fill? The reason I use fill is because I'm changing that entire area. If I wanted to change the color, I'll show you what that will do. Color equals, let's just go with PRPLE. That is going to give me an outline, right? So that is going to give me the outline. And I'm going to leave it on there. Like, I don't think it looks super good. You know what? Let's just take it off. So let's go ahead and get rid of that. Now what we'll notice is that we have a pretty big problem here, right? We can't see any of our axis labels, and it's very difficult to see the axis text. Well, we can adjust both of those by going to axis.title. We're going to go with element. Now, what do you think we're going to use? Element text or element rect? Element text, obviously. We're going to go with color equals hot pink. Now what you'll notice is that there is a bit of a correspondence here. So anytime I'm using element text, I'm using color. Anytime I'm using element underscore rect, I'm using fill. Now what we want to do, we also want to change this axis, axis.text, element underscore text color equals, let's go again with hot pink, P-I-N-K. All right, so now we're looking pretty good. I like almost everything there. The legend still needs a little bit of work. So how do we adjust that legend? Well, it follows the same format as everything else. So we're going to go with plot, P-O-T.legend. Oops, sorry about that. Legend. We're going to go with legend.background element. Obviously, we're going to use element rect again. We're going to go with fill equals, you know what, let's just keep it consistent here. Let's go with B-L-A-C-K. Let's give it a color equals white to give it a white outline. Okay, that is looking better. Obviously, we have the same problem now. We can't see anything in there, so we need to change that. So let's go with legend, L-E-G-E-N-D, dot, and what can we change here? So let's go with legend dot text. We're going to go with element underscore, and of course we're going to go with text. We're going to go with color, C-O-L-O-R equals white. Looking good there. And then the last thing we need to change is that title, right? So let's go with legend dot title element underscore text. We're going to go with color, C-O-L-O-R equals W-H-I-T-E. Okay, now we look really, really good. One thing just for contrast, I am going to get rid of this alpha, this transparency here. In my opinion, this looks really good. Now, obviously, the pink isn't an academic color. You know, it's a little bit of artistic flair here, but you could easily just as easily change that to white, whatever. One last thing that I do want to show you. We have a lot. This kind of trails off really strong, right? So like anything after 10,000 on the price, we're not really having a lot of meaningful data. Well, it is meaningful, but we might not want to focus on these extreme values, right? We might want to just zoom in, let's say from 0 to 10,000. How would we do that? The way that we're doing that, we're going to go with plus, we're going to go with chord underscore Cartesian. Now we can pass in the x limit and the y limit. So xlim equals, now we're going to pass in here two separate values. So we're going to pass in the leftmost value, which is obviously going to be 0, and we're going to go with the rightmost value, which let's go with 10,000. What this is going to do, it's going to zoom in our chart to that specific area. Now, we don't really need it here, but just for the sake of completeness, let's suppose we wanted to do a y limit as well. We wanted to go with 0.000, so this is 10 to the minus 4th. Let's go with 0.0001, and then let's go with 0.0003. What that's going to do, it's going to zoom in on those specific things that we wanted as well. So that is how you create and customize a density plot in the R programming language using ggplot2. Obviously, there is a ton more things you could do. You could get as fancy with this as you wanted, but if you're a beginner and you're just trying to produce a nice looking graphic for an assignment, for a project, whatever the case may be, that should get you most of the way to where you need to go. So, as always, thank you so much for watching the video. I hope you found it useful, and I hope you enjoy the rest of your day.